Welcome, ladies and gentlemen, and congratulations to making it to the summary for solving a systems of two linear equations using some elimination. So I just want to kind of summarize what I wanted you to kind of take out of the course, as well as kind of end with some tips and tricks, as well as some common mistakes that I see through students in my classroom as well as online. So basically, when we're trying to solve a system of equations by elimination, what we're basically looking into doing is taking two equations and making sure that the coefficients of one of our variables, x or y, are exactly the same, either both positive, both negative, or one positive, one negative. And then we're going to add and subtract those equations to get a coefficient for one of the variables to be 0. And what that does is that now eliminates one variable. And by adding the equations, now we have combined the equations to find the value of one variable. Once we solve for that one variable, we take that value and plug it into one of our original equations, and then solve to find the other solution. And therefore, we have the value of our x or our y or a or b, or of our two variables that we're looking for. And that's going to represent the intersection graphically of our two equations. And then we go look into identifying what type of solutions we have: consistent, inconsistent, or independent and dependent. So let's kind of go over some tips and tricks that I've kind of developed, while teaching elimination. The first thing is determining the smallest GCF. Sometimes I see students that they want to add, use their multipliers as much as possible. But for instance, like if I have 2x minus 5y equals 10, and 4x plus 4y equals 20 or something, right? Well, they say, oh, well, that's negative and positive, so let me go and get 5 and 4 to be common denominators. Well, yeah, or get the same GCF. Yeah, that's fine, right? But then you'd have to do that, though, you have to multiply the top equation by 4 and the bottom equation by 5, right? Well, if you notice, to get 2x and 4x to be the same, all I really need to do is just multiply the top equation by 2x, and I'm good to go. And I didn't do that. Evaluate easiest, add and subtract. Another one that I just thought of is when I see students applying their multiplier, you got to make sure you multiply the 2 times every single term. Actually, that's a common mistake. A common mistake is not multiplying your multiplier by every single term. They think that they can just multiply 2 times this and this, but that's like multiplying one side but not multiplying the third side, right? When we're applying a multiplier, we're producing equivalent equations. That means the equations have to have the same value. So whatever you multiply on the left side, you have to multiply on the right side. Another kind of tip and trick is always look for addition, not subtraction. So I can see why the students would like to multiply by 5 and 4, right? Because here's one negative, here's one positive. So I can just simply add the equations, right? And that's good. And I don't see a problem with it. Because if I multiply by 2, I have a positive 4x. So to eliminate the x's, I would have to subtract the equations. And again, I do not like doing subtraction because it just opens up the door for more mistakes. Because I think more students are susceptible to making mistakes with subtraction than they are with addition. So rather than you having to use this method so I could add, I can just multiply, though, everything by a -2, and then I add the equations. So that's a good little tip and trick. Last one is evaluate your equations. Sometimes we'll have easy equations, sometimes we won't. Basically, when I look at this, and let's say I solve this systems of equations, right? And let's say I get x, let's say I solve for x, and x equals 17 or whatever. All right. Now, I take x, and I need to substitute it back into one of these equations, right? So how do you choose which equation to substitute into? Well, you can look at it and say, there's really there's really not an easier equation or the other. But remember, we want to solve for y. Well, if y is negative, or there's like a large number multiplied by y, usually that's not your preferred method. You usually want to have your easier. It would be really nice if it was already solved for y, and I would just plug it into that one, right? But usually, we always like to have the variable that you're trying to solve for be positive. That usually will make it easier. And obviously, if it was solved for y, plug it into that equation, because then you don't have to do any more math by solving for the y. You can just evaluate. So common mistake. Again, students using too many multipliers. Kind of like my case here, wanting to multiply by the 4 and the 5. Or just multiplying by higher numbers. Maybe they don't notice that 5 and 4 are your multipliers. Maybe they go to like 10 and I'd have to look it up, or 12 and 12 and 16, that'd be 20, 20, 25. So 12 and 25, maybe? No, that's way too high. 12 and 15? Yes, 12 and 15 would be another multiplier. So they kind of go too high. Always look for the least amount of times you need to multiply the equation. That's going to save you a lot of time. But I see a lot of students, that's where some mistakes. Again, mistakes coming from subtracting. They subtract the equations and they don't read it out loud, or they don't distribute the negative sign. So when they subtract the equations, they usually make some sort of small error. And the last thing is not writing out the solutions. You know, if I say x equals 17 and y equals 3, that's fine. Depending on what your teacher is, you're obviously going to want to listen to your teacher and say, how would you like my solution to be written? A lot of times when we're looking at these graphically, these represent the coordinate point where the graphs intersect. So we can rewrite them as a coordinate point, or we can write them as a solution. But one thing that really gets me is sometimes I'll see like x equals 17 over here and y equals 3 over here. And a lot of times, they might have extra work that either they don't portray to me and it covers up whatever their solution is. So they get it wrong because they only show one solution. You got to make sure, remember, when we're solving a system, we're solving for two variables. So don't just solve for x and say, oh, my work is done. You got to make sure you're solving for both variables. So there you go, ladies and gentlemen. That is just an overall summary of what you need to know to solve a system equation by elimination. Thanks.